Okay, here's another problem. Absolute value of complex numbers. Here's an example, 3 plus 4i. There's a little formula for this, but just to show you, it may help you to remember it. A little bit of why you're doing what you're doing. If you look at graphing a complex number, remember this is your real number, and my real number is 3. When I say this, I'm referring to the horizontal axis. The vertical axis is your imaginary number. So if I count up, this would be I. This would be 2i, 3i, and 4i, so forth. If I go down, negative I, negative 2i, you get the point. Negative 3i, negative 4i. Here are just real numbers. 1, 2, 3, 4, 5. Over here your negative values, okay? If I plot this point, this is a point, if I graph this on a complex number graph, I'm going to go over 3 real number values, go up 4i here. That's 3 plus 4i, graphing this on the imaginary number graph. What we're looking for essentially when we find the absolute value is if we were to draw a right triangle here, this is 4 units, here that's 3 units. What we're really looking for is this value here, the length of the diagonal, which we're really just using the Pythagorean theorem to find, which is going to be 3 squared plus 4 squared equals unknown squared, then solve it. But there's a little equation for that, so all you have to do is plug the values in the equation. It looks like this: square root of 3 squared plus 4 squared, and you just do the math. That's 9 plus 16, that's 25. Square root of 25 is 5. That's it. So you can remember this formula, and I'll write the formula out here. Square root of a squared plus b squared, if it's in a plus bi form. And that's it for that particular one. Okay, something to note, the next type problem, there are several problems. Just remember, go over the Pythagorean theorem, go over your trig functions. But here's an example. You need to know angle of depression. Angle of depression, here's an example. I just found a website. You could type this in, and there's 1,000 websites that talk about this. But angle of depression, here's the observer. This is the horizontal. Angle of depression is the angle that's down from the horizontal to the line of sight. Okay? Angle of elevation is just the opposite. The observer is here, but it's going from the horizontal again, line of sight here. Okay? Okay, here's our problem. An Apache helicopter is flying over a building at about 1,000 feet. Let's draw a building. Here's our building. Here's our helicopter. There's our helicopter. Sad looking helicopter. I'm just going to make a little X here, okay? Alright. It's flying over a building at about 1,000 feet. The pilot observes a tank at an angle of depression of 48 degrees. How far is the building? How far is the tank from the building? Let's see. So I know this is 1,000 feet. I know this is my horizontal. So my line of sight is here, and here's my tank. And we know this is 48 degrees. So therefore that makes this is 90. So 50, that's going to be 52. And in order to find this angle measurement, I'm going to have to pause and go to the next video.